Example 21.1 says find the exact solution of each equation, and we're going to continue with parts D, E, and F here. This is going to be more use of the one-to-one property. So let's take a look at part D. We have 3 to the x minus 7 is equal to 1 over 243. So in this situation we have a rational number that is equal to a exponential statement. So I'm going to leave the exponential statement alone as 3 to the x minus 7. But I want to think about rewriting 1 over 243 with the power of 3, so that way you can have the same base. So we have to think powers of 3. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and 3 to the fifth is going to give us 243. But what we have here is 1 over 243, which would be the reciprocal. So if I was to put a negative on the exponent, that would make the answer become 1 over 243. So let's use negative 5 as the exponent, and now I can set the two exponents equal to each other. X minus 7 is equal to negative 5, in which case I then get x must equal positive 2. Let's try the next one. We have 7 with an exponent of x minus 2 divided by 6. So all of that fraction represents the exponent. And then on the right hand side we have the square root of 7. So I don't particularly care for the square root. So I'm going to rewrite it as 7 to the 1/2 power using our rational exponent there. And now 7 becomes the base on the right hand side as well as on the left hand side. So I don't actually have to do anything with the bases here. I can just go ahead and set the two exponents equal. X minus 2 over 6 is going to be equal to 1/2. In which case you get to this point and you have a proportion, and there would be a number of ways that you could solve a proportion. I'm going to multiply both sides by 6, so that way I can have x minus 2 is equal to 3, in which case x would have to be equal to 5. And for the final example on this, part F, I have 8 to the 1 minus x is equal to 4 raised to the x plus 2. So neither 8 nor 4 is going to be easily rewritten as one or the other. So let's go ahead and try to rewrite them using a different base. Each one of these are going to be powers of 2. 2 to the second power will be 4, and then 2 to the third power will be 8. So I'm going to rewrite the left-hand side as 2 to the third power raised to the 1 minus x. Right side will be 2 to the second power raised to the x plus 2. So this is going to be 2 raised to the 3 minus 3x. And on the right hand side I'll have 2 raised to the 2x plus 4. And now I set the exponents equal. 3 minus 3x is equal to 2x plus 4. And then you solve this linear equation. I'm going to add 3x to both sides, getting 3 is equal to 5x plus 4. Now I'll subtract 4 from both sides to get negative 1 is equal to 5x. And then finally divide both sides by 5, and then I have negative 1/5 is equal to x. And this is our one-to-one property for exponential equations.